There is a big buzzword in industry called DFM, Design for Manufacturability. DFM. Now, all the good companies do DFM. There's some empirical checks whether design has this, that. So if all this is there, then it is readily manufacturable, not otherwise. But while doing that exercise, if your designer doesn't know what is the accuracy performance of the machine that you have on your shop floor, what is the record of competency of your operative who has been producing, unless you do it with that data, doing it on paper, sitting in a design office with some numbers, you're only fooling yourself. Management driven organizations have different concept of innovation itself. They have corrupted the meaning of innovation word. Innovation, according to them, means something which should get you some numbers in your business. But that's not innovation. By definition, innovation is an idea copied from some other domain, translated into your domain with some outcome. But here they want to define the outcome upfront. This is the KPI you want to achieve. Now you work back and innovate. That is just managing performance. Finding some way so that those numbers will come out by hook or by crook, whatever. Breakthrough improvement is something which generally cannot happen by design. You can't have a breakthrough out of the box thinking by design. That okay, now for 1 hour you think out of the box. Doesn't happen like that. Bright ideas will come like a brainwave when they come. And for out of the box implementation, one has to have that kind of flexibility, resources, that kind of budget to be able to deviate from regular things. When the budgets are distributed, how they are distributed. Last year, what was your actual expenses? Okay, next year you try to save 10%. So it is sliced by 10%. Now suddenly what out of box you can do with that kind of boundaries.
Hello friends, I am Avinash Khare, your host, and I welcome you to this series, Technocrat Talks. In this series, we will be dwelling on our blind spots, which have shackled our thinking and which have preconditioned our perceptions into a certain template. We have been suffering because of that. This we are doing through application of engineering sense and cold logic. Welcome to this analytical discussion. If you are new to this channel, please subscribe. Please press the bell icon to get the notifications. If you like the talk, please like it and share it with your friends, so that we increase the community of like-minded, curious minds to take the movement forward. Without much ado, let us start today's talk.
Can you tell us more about the stereotypes that technocrats face in the industry?
Well, there are stereotypes not just in industry but everywhere else also. In the industry particularly, well, if you talk of different functions, for example, let us say somebody wants to go in a design or R&D function. He or she has to be at least a postgraduate, MTech, preferably PhD. That's the stereotype. In fact, there are cases when bright young pass-outs, graduate engineers are interested in R&D function, but they get dissuaded because they are told that without post-graduation there is no entry in this area. Okay, so there is a stereotype affected that unless you have this background, you are not fit for this job. For sales or marketing, probably there will be a prerequisite of MBA. So that will be dissuading them from doing that one. Coming to shop floor also, there are clear-cut templates for different roles, and you have to actually fit into that template, and that is a painful task, to fit your personality into a fixed template. For example, the template of a production in charge is someone who is day in, day out counting jobs in a mass production setup. And all he does throughout the day is a postman's job. If machine breaks down, he calls the maintenance man. If maintenance man does not come, he complains to the big boss. If there is an HR issue in the shop, he calls the HR man. If there is a quality issue, he calls the quality man. If the material does not come in time, it phones the material manager. So basically, the person is only doing postman job, but what is his real contribution? He is just there positionally, controlling a big area. And apart from this, what he is supposed to do is the performance. Performance meaning productivity, meaning electricity consumption, meaning tool consumption, meaning. But generally, he has no handle on any of those things, but he is reporting that data. And he is trying to control it somehow. Discipline, okay, some people going for lunch 5 minutes earlier, etc. Those things is watchful. But as a technocrat, what is his profile? Does he know how the machine works? No, he need not. Does he know the speed feed? No, he need not. Does he know how to read CAD drawing? No, he need not. Okay. So from learning point of view, from technology point of view, it doesn't make any difference what the factory is producing. Whether the factory is producing toys or producing shoes or producing biscuits, the role of production man remains the same. So he is not product competent, he is not process competent, he is not machine competent. He is just information competent, that okay, gathers information and communicates. Compiles the information, puts it on the board. And just maintaining the discipline, so to say. Okay. And some hygiene aspect like cleanliness and all. Okay. 5S and stuff like that. Okay. But do you require a graduate engineer to do this? Actually, anybody can do this. So that is the profile of a production. Similarly, there is a stereotype for quality. Quality man would be able to do lot of root cause analysis kind of stuff, exercises, and find out the root cause for by statistical techniques and SQC and all that blah blah blah. But he doesn't know how the machine works. He doesn't know the speed feed. He doesn't know the product design also. Why the product is designed in a particular way, that quality man need not know. He knows only what the tolerance is written on the drawing, whether against that tolerance is there or it's not there. And then what is the sigma level of the shop floor, what is the CP, CPK, all that stuff is thorough. But yes, if there is some problem, how to solve that problem? He can just give you some pointers that, okay, look at this based on his wishbone diagram, etc. But then he can't rectify the problem himself. He can't give a solution. He can just put lot of data because he has access to data. Okay. That is the quality man. Maintenance man is equipment competent, but he is not process competent. He knows the machine, but he does not know the manufacturing process. He does not know the speed feed. He does not know the tolerances. He just knows his machine, equipment. What goes wrong, why it goes wrong, what is to be done if something happens. That's all. I always say that an R&D man and a designer knows how exactly a machine works. A machine designer will know how the machine works. Machine R&D fellow will know how the machine ought to work. A maintenance man has to only know how the machine doesn't work. Very simple. That's like a doctor's job. As long as body works okay, you need not know how it works. When something doesn't work, you only know that yes, what is to be done to diagnose, what is to be done to cure. The job is done. That's the template. So similarly, you have maintenance template who is only restricted to finding fault diagnostic techniques, tools for diagnostics of course, and systems and procedures for doing dismantling, assembly and stuff like that. And of course reading the technical drawings and all that. Fine. But then he doesn't know the product, he doesn't know the manufacturing process, he doesn't know the other things. So one has to get placed in one of these templates.
How do you think the rigid template that technocrats have to comply with affects their potential to innovate and bring breakthrough improvements?
Now, for breakthrough improvement, you have to breach the domain boundaries. Actually, each domain, each template has its own boundaries. So, usually they are taught to grow within those boundaries. But they don't know how to venture into another domain. So, they will stay within their domain. Within the domain, they are tied down with the stiff discipline of that domain. They cannot think any other way, they have to think in that way only. So, out of the box things are ruled out of the box things don't come because their thinking is stereotyped. It works only in that way, they don't see other possibilities at all. And in design department, there is often a problem that they are very secretive also. I don't know what is there to hide, but then they are very secretive for reasons best known to them. And they don't like anybody infringing into their domain. So they incarcerate themselves into their own ivory tower. They don't come out of it and they don't let anybody come up there. So they have their domain boundaries and they do something which only they know. And so that is certainly hampering the collateral development and things which are interdisciplinary. I have seen organizations where bosses don't like if you talk to somebody from other department. Happens up to this level also sometimes. They are fiercely secretive and that's what is hampering, and they are templated. We will only do this and not this. This only is our KPI, this only is our scope, rest we are not concerned. So that severely limits the thinking potential also. Innovation comes much later. Innovation is something where, let us say you see some phenomena in biology or medical side and you apply the same context in engineering or vice versa. That is innovation. You borrow the idea from some other totally different domain and implement in your domain. That is what is innovation. But if somebody who is so much sealed in his own silo and his own profile tightly is unlikely to know what is happening elsewhere. And how to translate that thing to our context is further a tall order. So it will not happen. And to top it, what happens that the so-called brainstorming techniques which are popularized by consultants all over, you have to think in a particular templated way. Say, draw Ishikawa diagram, draw this, draw that, root cause analysis, you have to do in a particular way. That process kills the creativity. First of all, they say there is a jargon used called 5 whys. If something goes wrong, 5 times you ask why, then you would arrive at the root cause. Okay. Now suppose I am a maintenance man and machine has broken down and I have started the machine. Somebody comes and asks me, have you done 5 why analysis? Why did the breakdown happen? Then I have to explain that gentleman that, look my dear, I have taken 3 hours and solved the problem and machine is running now. Number 1. If I have to answer 5 whys, I can't be doing that analysis sitting on the table. That would be pointless. It will be an invasive investigation. Are you ready to give the machine to me for investigation of 5 whys? And the fellow ran away. Just imagine if a doctor tells you, no, first I will do 5 why, then I will give you medicine. How does the patient feel? Okay. How will a patient feel if the doctor insists on doing 5 why first? Or he starts drawing that Ishikawa diagram. Now that again, it's a beautiful technology, Japanese technology again. But then, for each argument that you do with that diagram, there has to be some investigation physically. It could be invasive. Are you ready for that? Or it is just for the namesake that on table you are saying, nahi, ye nahi hai, ye nahi hai, ye nahi hai. What good is that is? You are just debating, no, iska problem nahi hoga, this is not the problem, this is not the like, most probably this is the problem. So it is guesswork only in the end. So it throws out the systematic template that is there out of the window. Once you start doing it on table, just by negotiating, scientific basis is gone. And for collecting data, you need time. You need efforts, you need money. Does it deserve that kind of money and effort and time and downtime? That's the question. So, many times what happens that management consultants and those who preach all these things, they don't know what they are talking actually. For example, the popular slogan is there, zero defect, zero effect, zero finance. If it were possible to have zero defect, why do you have tolerances in engineering drawing? The fact that you are having tolerances means you are recognizing that nothing is perfect and nothing can be perfect. The question is whether the error or defect is within tolerance or it is outside tolerance. And it defects as much on the magnitude of defect as it depends on the magnitude of tolerance being given. So it becomes subjective again. Anything can be shown there. Right? So the problem is managers don't know what they are talking, but engineers, technocrats have to know what they are talking because they have to make it happen in the end. So we have to recognize that yes, there will be certain defects, there will be certain anomalies, whether it is within this limit or this limit, that has to be seen. Okay. There is a big buzzword in industry called DFM, Design for Manufacturability. DFM. Now all the good companies do DFM, Design for Manufacturability. There's some checks, empirical checks, whether design has this, that. So if all this is there, then it is readily manufacturable, not otherwise. But while doing that exercise, if your designer doesn't know what is the accuracy performance of the machine that you have on your shop floor, what is the record of competency of your operative who has been producing, unless you do it with that data, just doing it on paper, sitting in a design office with some numbers, you are only fooling yourself. That kind of interrelation is not there for designer or for QA man to know what is your machine fidelity, what is your machine performance, what is the thermal variation within machine in 24 hours. As per data sheet, you harp on saying that this machine is supposed to give boring accuracy of 10 micron. But you don't realize that it is a 6 meter long machine. And every day, even if you don't do anything, you just put a dial. The machine breathes by 0.5 mm in 24 hours. Where is 10 micron? The thing is, technocrat knows these things. Technocrat has to know these things. But a manager says, no, I have bought a machine which is supposed to give 10 micron. You see, here is a report. He goes by the paper. And that report is like report which automobile company gives that my vehicle will give 80 kilometers per liter in fine print under test conditions, which will never match with your real conditions.
The qualifications required for a technocrat, for example, in R&D and in design engineer, they are similar. Do you think this is essential?
In industry, when you say R&D, actually we write R&D with the same font size, R&D. But practically, if you see, R is actually very minuscule, if at all there. It is D, which is much bigger. So R&D departments, more often than not, do only development. They don't do basic research. Basic research, you forget it. Even applied research they don't do. They do only development. Product development, and not even that, it is often only testing. You try some variants, you try some different aggregates, you just do testing. You put it in testing cycle. That is the job of R&D more often than not. It's not basic research what is done in universities and institutions. It's not basic engineering research. Designers also, they never do any calculations. They just draw the CAD model, cut and paste on the screen, and build up virtually an assembly based on the standards that are available. There is no engineering calculation or engineering fundamentals involved usually in design. They follow thumb rules. And they churn out CAD models and drawings, and that's their outcome. So the academic element is actually sorely lacking in most design departments. There is no academic element, not much. Beyond the terminology, nothing much. No basic engineering concepts are much used. It is mostly applied things. Okay, pick up this block, fix it, pick up this block, fix it, marry their specifications, that's it. So that is design. And research is only development, basically. Testing and development. In that sense, they are also not research per se. But wherever research also happens in research-oriented organizations, for example, research labs and all, you have research centers in academic world. Now those work differently. But there also, sometimes you get an impression that they are working like our old Gurukulas, isolated from the rest of the world. They are in their own world, and academicians have developed their own language for themselves by themselves, employing a lot of arithmetic, God knows for why. Okay. So they have some jargon which they only understand. It's like making something very elitist so that it is cut off from the masses. It's the same mistake that our ancestors made by isolating it from the masses, making it elitist, isolated from the society. Okay. And many times the seniors in those research organizations talk no different from clergy of medieval times. You come up with any new idea, it will get thrown aside. Okay. As something which is just not acceptable in the scheme of things. So, whether innovation is possible in such setup is a question mark. You can follow the same rules of that silo and reach on top, but you will remain isolated in your own world, quite disconnected from the industry. So that is what tends to happen in pure academic fields also. And then it becomes like a hypothetical syllabus which is made for passing the exam. After that, God knows what for anything is used anywhere. Yeah. So that grand isolation comes between academics and actual day-to-day life in industry.
Are innovative ideas welcomed by management-driven organizations?
No, management-driven organizations have different concept of innovation itself. They have actually, I would say, corrupted the meaning of innovation word. Innovation, according to them, means something which should get you some numbers in your business. But that's not innovation. By definition, innovation is an idea copied from some other domain, different domain, translated into your domain with some outcome. But here they want to define the outcome upfront, that this is what we want to do, This is the KPI you want to achieve. Now you work back and innovate. But that's not innovation. That is managing performance. That is just managing performance. Finding some way so that those numbers will come out. By hook or by crook, whatever. So, but that is not innovation. But that is what is recognized as innovation. Now, I give you another example. For example, you have some new technology available now. Now you plan to buy that technology, implement it in your work system and get some advantage out of it. Okay. That's what I would call as a pro-technology organization. Proactively, you scout for technology, you identify some technology that is going to improve your performance dramatically, and you procure it. But you have to invest certainly. But investment is an investment. Investment is not a muda, investment is not a waste. But in management, they think it like as if it is a muda. Capex is a muda. You don't want capex. So you don't want to invest. You don't want to buy technology. You just want to see the result somehow, anyhow. So obviously, it will be managing. There will be a lot of managing and less of the real things happening on ground. That is what is recognized as innovation. Some jugaad done by somebody, you claim it as it is a great thing, though it is jumping 4 ladders and bypassing something and bypassing the process and taking some shortcut. It will have some other implication which will get reflected some other time to somebody else's KPI. But then that's what it is. That is recognized as innovation. So, I believe that the real innovation has to be done by technocrats and better be done by technocrats and proper solid based on technology like this one, putting a SIM card everywhere. This is innovation. This is innovation. But then just doing something of cosmetic value to change the appearance on your Excel sheet, some numbers should change somehow. That's not what I call as innovation. Okay. And many times people say that, okay, I downsize my organization, that is innovation. I lay off 10 people, that is innovation. Is that innovation? Is that innovation? That's not innovation. So, there is a difference in perception about what innovation ought to be.
Do you think the isolated ivory towers of R&D institutions and design departments impede the entry of other organizational functions and limit the potential for cross-functional collaboration? And how does that happen?
Certainly it does happen. See, nowadays, again I will refer to Industry 4. Now we are saying that there should be electronics into everything. Everything meaning our product. If we are into machine tools, probably into the machine tools. If we are in cutting tools, then into cutting tools. If we are into stamping dies, then die and mold. If we are into measuring instruments, then instruments also have to have electronics. They should be able to send the data directly on Wi-Fi. Correct? So now there is a need, a desirability and a possibility that you could have interdisciplinary requirements into every field. Now if certain field, for example say die mold, is dominated by mechanical engineers and they don't allow anybody from hydraulics, anybody from electrical electronics into that particular domain, it will severely restrict the way they will keep on designing their things. Minus all these high-tech things which are supposed to be there now. Now that is what will become a limiting factor after a while. Okay. And nowadays you can't have watertight compartments. In many areas there is application of AI/ML, for example. Now, if you don't want to allow a software guy to peep into your domain, how will that happen ever? It will never happen. Because you will not learn AI/ML, and that fellow who knows AI/ML is not allowed inside your domain. Then how does it work? It will not work. As simple as that. So things have to open up, things have to become interdisciplinary. You can't restrict, you can't brand a fellow that he's a mechanical engineer, so he can't do any electronics. He's an electronics engineer, so he's not allowed to see my mechanical drawing. You can't do that anymore. So you have to break out those templates. You have to come out of those templates and have a lateral interaction, interspecialty interaction, like it has happened in medical, for example. You see the sophistication level of medical equipment. There is a lot of software, a lot of electronics, a lot of technology, diverse technologies which are coming into medical diagnostics. Same thing has to happen in engineering. But with these silos and watertight compartments, how could it happen? It will never happen. So I will not say that interfunctional transparency, yes, that should be there. But more than that, interspeciality involvement has to be there in each and every function. That's the need for the future. That's the requirement for Industry 4, Industry 5, etc., what is coming.
Would you like to comment on how technology is treated by different departments or different roles, like let's say production, QA, planning, etc.?
No, production people are only content with the management people sometimes used to take pride. When they teach you sales and marketing, they say it doesn't make any difference whether you are selling lipsticks or you are selling bullets. If you know how to sell, you will sell. But then that's not so. That's not quite so. Selling a turbine, selling a pump is not same as selling FMCG. Rural marketing is different from urban marketing, of course. Very different. Sales and marketing is different from market development. There are different roles, obviously, within that. And many of the roles, you have to have a good technical exposure for being able to satisfy the customer, for being able to do something out of the box. And in shop floor also, in production people are only busy counting rejections and counting the number of jobs in mass production. They avoid technology almost totally in the process. Quality people often act like lawyers only. They follow the rule book and nothing beyond. They are not tech savvy either, many times. Other than operating CMM maybe. Yeah. And operating some of the softwares. Design people follow their own design processes and they are blind to other technologies. They just are content within whatever is there in their domain. Now things have to widen a little, obviously. All these boundaries have to be breached so that people get a lot more information. What happens many times that a fellow comes to an industry, he is thrown into a particular function in a particular department. Of course, he learns that job in that particular department and the machines in that department and people in that department and all that. But then there is no way of systematically giving him input about other things which he is not able to see there. What else is there in the world? Somehow organizations are not keen to impart that knowledge to their working level people. Okay. So they don't know of many possibilities which are there, Many people are doing outside. So that kind of lateral spread is rather limited when one goes in a silo kind of a thing in a templated profile. So that's what has to happen. Things have to ease out, things have to be more dynamic.
How do you think the focus on commercial and tangible aspects of technology affects the potential for breakthrough improvements in the industry?
Now, breakthrough improvement is something which generally cannot happen by design. You can't have a breakthrough out of the box thinking by design. That okay, now for 1 hour you think out of the box. Doesn't happen like that. Bright ideas will come like a brainwave when they come. When you see something on internet, probably some idea will click. But here our assumption is that everything has to be driven by KPI and by the business requirement. So you are forced to innovate depending on business requirement. You are forced to do out of box thinking based on business requirement. Now, that is not out of the box. And for out of the box implementation, one has to have that kind of flexibility, that kind of resources, that kind of budget to be able to deviate from regular things. Now, usually how organizations work is, when I am talking of budgeting, when the budgets are distributed, how they are distributed. Last year, what was your actual expenses in certain head? Okay, next year you try to save 10%, so it is sliced by 10%. That's how budgets are given. So budgets and resources that you get will have a historic bearing on what you have been achieving based on that. Now suddenly what out of box you can do with that kind of boundaries, with those kind of resource limitations, what out of the box could be achieved? It cannot be achieved, it cannot happen in that kind of working. Unless the top man himself is driving something, or you give a brilliant idea to the top man and he gets convinced and he bypasses all the system and allows you to do that. Otherwise, following by the systemic way of working, out of the box is not possible. System itself will constrain you to working in a particular way only.
In what ways can industry and institutions better foster a culture of innovation and break free from the constraints of stereotypes and compliances?
See, basically what happens that in industry, the one thing is that you learn from your immediate neighborhood, immediate environment. The kind of machines you have, the kind of colleagues you have, cross-functional also, okay, suppose, granted, a cross-functional interaction is there, so okay. You will learn the practices within the organization, okay. Now that is one way, that is what usually is expected to happen readily. Beyond that is, of course, learning from some other organizations, some other benchmark organizations, through some visits. But most of the learning happens through some presentations made by some technology developers. Now what happens that those who want to sell their hardware and software, they are interested in visiting you and making some presentation of the recent developments done by themselves. Okay. Now if you allow that channel to flourish, yes, you get some inputs on what is happening in the market, what is the latest thing in the technology which you could innovate into your context. Okay. Now that is a good channel, but there is a limitation that the fellows who are coming and giving you those inputs are interested in selling their things. So it would be a biased view. They have a vested interest. So they will give you the information as it suits them. For example, if there is a competitive technology which is better, they will not tell you that. They will tell you what they have come to sell. And they will prove that that is the best thing around. Right? But you don't take purchase decisions like that. I mean, you always have norms of three quotations and you want to consider alternatives. Even not just alternative equipment, alternative approaches also. Approaches to automation, for example. And those. So you would want unbiased comparison of different possibilities to evaluate before you decide. Now that could only be given by somebody who doesn't have vested interest in selling anything. So usually educational institutions and academics have no particular interest in selling any particular brand product to you. So it is likely that they would give you a balanced view of pros and cons of different alternatives that you have at hand. So it is useful to have some interaction and some training sessions and some exposure to academia from that point of view. Okay, where you get the balanced input of what is what in the market, how the two technologies compare, where which is better, and all those kind of things can be easily accessible from academia. And those are by far the latest developments. So, yes, interaction with academia is good. Only thing is academia has to adapt to the way of industries, because usually they start any talk by writing a big equation on the board, which throws off the industry people because they are not comfortable with so much of mathematics anymore. So, I mean, I always say that job of good teachers is to make a difficult subject very easy. But sometimes by going through rigor of mathematics, we do the reverse. We make an easy subject look very difficult. Now that is something which has to be overcome in dealing with industry. Things have to be made more palatable. Now somebody who doesn't know laser and you are teaching him the benefits of laser cutting, for example, you have to know how to explain without going into quantum mechanics of laser. Right. So some tuning up is required there, but it can be done. It's doable easily. I'm not saying that it is difficult. It is doable.
Well, with this, we have come to the end of today's talk. Please take this movement forward. Please share it with your friends. Open Mind is an engineer's workshop, and our goal is to engineer our future. Please press the bell icon to get further notifications. Please like if you have liked the talk, and please do let us have your feedback, your ideas, your comments, your suggestions. Hope to see you in the next talk, Technocrat Talks. Till then, be happy, enjoy. See you next time. Bye-bye.